Now, UPS DG interaction, the perfect storm. Perfect storm. This is very deadly combination, I'm telling you. Why DG plus UPS is problematic? Why? And how it can be overcome? That also we'll see. Generator designed for linear resistive loads with stable power factor. While designing, it is for linear loads. UPS rectifier is worst possible load, very worst. Non-linear, pulsating, current draw, poor power factor, high harmonics. Okay, very deadly. Generator voltage regulation struggles to maintain stable output when feeding UPS. Why? Because distorted. It will distort the waveform. It will not understand whether it is giving proper voltage or not. It's reference point. It will take the feedback, right? We have seen. It will take the feedback. This thing, voltage regulator, take the feedback from the load side. But if UPS is there, it will be distorted. Like here, here, here. It will be confused. So, stable output while feeding UPS. No stable, unstable. So, UPS is distorted input. Now, what will happen to UPS? UPS will see I am getting power, but it is distorted. Why it is getting distorted? That is also contributed by generator. Both things are culprit here. Both the things. Okay. See, we will go in deep. So, UPS is distorted input may reject generator and run on battery until depletion. Okay. And why this happens? Wait, I'll tell you. This is why perfectly sized UPS DG system fail during first real power outage. It will fail if it is perfectly sized. Oversizing is very much required. Now, voltage distortion. What happens? UPS harmonics interact with generator. Now, UPS has generated harmonics. It will interact with generator. We have already seen what is the formula. XL is equal to 2 pi FL. Okay. L is constant. Generator is a coil, winding, right? It is an inductive load. And this XL, inductive reactance, is directly proportional to frequency. L is constant. Frequency. If fifth harmonics, what is fifth harmonic frequency? For 50 Hertz, it is 250. For 60, it is 300. If high frequency, then what will happen? XL will increase. Okay. If this increases, this will not accept. See, generator will not accept this current, fifth harmonics current. It will reflect it back. See, you are understanding. This is creating, sending here, it is again reflecting back. It depends on the magnitude of frequency because it is directly proportional, XL. So, high inductance. And because of that, what is happening? Impedance. See, UPS harmonics interact with generator impedance, creating voltage TSD of 10 to 20%. Voltage bouncing back. Harmonics, total distortion increases. Bouncing back will multiply. So it will become 10 to 20%. Can exceed UPS input window tolerance. UPS also has input window tolerance for the this thing, harmonics. If it is going 20% beyond that, it will stop accepting the power because it is contaminated for it, right? It will switch to battery. See, this is what boomerang. Okay, this has created harmonic, sent it to generator. This has reflected back, added back, and made it 20%, and this is shutting down and going on battery. So this was the cause. This has amplified it and again shutting it down. Next problem. Okay, this is one problem. Next problem, frequency instability. Pulsating UPS load causes governor hunting. Governor checks frequency, load frequency. Okay, and accordingly it will what? It will adjust the speed. Okay, 120f upon P, N is equal to, okay. So P is constant, frequency is dependent on speed of that generator. So if you want to change the frequency, you need to change the speed, and that is done by governor, by providing the fuel supply. Now what is happening? See, frequency oscillates plus or minus 2 hertz, right? So UPS may refuse to synchronize if frequency drift exceeds plus or minus 0.5 hertz window. This thing, governor of generator, will get confused because of distorted waveform. It will not be able to meet up this plus or minus 0.5 accuracy. And this accuracy, if is not met, what will happen? UPS may refuse to synchronize. UPS will not synchronize with the bus. What then it will do? It will go to on battery mode. It will refuse. No, this is a contaminated power. Frequency is not stable. Okay. And who is making that frequency unstable? This only UPS, because by sending the harmonics. Okay. This is the only cause, very cause. This is creating problem to DG and again refusing the DG. What kind of marriage is this? Very dangerous marriage. Okay. So that is the reason oversizing is required, so that impedance will be less, generator impedance will be less. Less impedance, then reflection will also be less. Okay. See, we'll see. So voltage sacs, UPS battery charger, third problem. Voltage sacs, UPS battery charger inrush after transfer. See, after you transfer the load to DG, what will happen? UPS battery charger will suck the current to charge the battery. If current increases, voltage will go down momentarily. Then what happens? 10 to 15% sag, voltage will sag. Then UPS sees under voltage. UPS will see, oh, this is not the proper voltage. No, I should not take this contaminated power. This is not a proper voltage. So transfer back to battery, an endless loop. Okay, taking power, transferring back, taking power, transferring back, endless loop. Start, stop, start, stop. Okay, that is why UPS DC interaction is deadliest combination, I have said in first slides. Okay, now why this happens? Generator has high source impedance. Impedance is important, right? So compared to utility grid, 3 to 15% high. XL is equal to 2 pi XL. Okay, we have seen FL, sorry. So that is why it is creating trouble, and utility is less than 1%. Okay, very less impedance. That is why it is not happening with utility. This impedance magnifies effect of harmonics currents and load transients. We have seen. So generator AVR response time is 100 to 500 milliseconds. Okay, if there is any correction in the frequency, its response time is high. Generator, slow device, okay, bulky and slow. So it's too slow for UPS rectifier dynamics. UPS rectifier tuck, 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 very fast. Okay, we have seen 20,000 we have seen. So in it is in milliseconds. This will never match, never. So governor mechanical lag creates frequency instability. So worse with this smaller generator. If generator is small, that is worst. So impedance increases as KVA decreases. This is fundamental physics, not poor design. Okay, impedance increases as KVA decreases. This is the physics. That is why this combination UPS DG is dangerous. Okay.